I welcome all the members for today's guest lecture on Fundamentals of Engineering Mechanics with AI Integration. In this session, we will explore how classical engineering mechanics principles are evolving with AI technologies to create smarter engineering solutions. Let us have the session outline. In today's session, we will begin with the basics of engineering mechanics and understand its basic scope and importance. Then we will discuss the core concepts of statics and dynamics. After that, we will explore how AI is integrated into engineering mechanics and examine the real-world industrial applications. And finally, we will conclude with the learning resources and future career directions. Let us now get into the main theme of the presentation. So, what is meant by engineering mechanics? Engineering mechanics is the branch of science that studies the main effects of forces acting on rigid bodies subjected to rest as well as motion. It is broadly divided into statics, dynamics, and mechanics of materials. Statics mainly focuses on equilibrium conditions. Dynamics studies motion and forces, while mechanics of materials deals with stress, strain, and structural integrity. These concepts form the backbone of all engineering systems. Now let us discuss the each subclassification individually, one after the other. First, let us go with statics. Statics is one of the most important branches of engineering mechanics. It deals with forces, moments, equilibrium, and free body diagram. Normally, engineers use equilibrium equations such as summation of forces is equal to zero and summation of all moment equal to zero. So this clearly means that which helps to analyze the static structures and missions. Applications involve bridges, cranes, trusses, and building structures, where stability and safety are one of the most important critical factors. Next, dynamics studies bodies in motion and is divided into two types, kinematics and kinetics. Kinematics describe the motion without considering the forces, while kinetics studies the forces causing motion. Important equation includes velocity and acceleration relations, Newton law of motion, work energy theorem, and impulse momentum principles. These concepts are widely used in automobile, aerospace, and robotics engineering. Now let us see how AI is being integrated in engineering mechanics. AI is transforming engineering mechanics in many several ways. Machine learning can predict the system structural behavior from simulation data. AI-enhanced finite element methods improve simulation speed and accuracy. Computer vision techniques helps to detect defects and measure the displacement. Digital twin enable real-time monitoring of structures, while large language model assist in solving engineering problems interactively. Now let us see AI-powered tools for engineering mechanics. There are several modern tools integrate AI with engineering mechanics. ANSYS AI supports intelligent finite element simulations. MATLAB with machine learning toolboxes helps to identify the system behavior. OpenFOAM uses deep learning for faster computational fluid dynamics simulation. Abacus AI predicts the material failure, while cloud platforms like SimScale enable AI-driven optimization studies. Let us now see some of the real-world AI used in engineering mechanics. AI-powered mechanics applications are already transforming industries. Say, for example, structural health monitoring systems use sensors and AI to predict cracks and failures in bridges and dams. Robotics industries apply AI for inverse kinematics and adaptive control. Automotive companies use AI in crash simulation to reduce testing time. Aerospace simulation, aerospace organization such as ISRO and NASA apply AI for topology optimization and fatigue prediction model. So what are the various learning path and roadmap? To build an expertise in this particular field, students must learn the fundamentals in statics, dynamics, and mathematics. Next, they should learn software tools like MATLAB, Python, and ANSYS. At the same time, they have to be well versed in programming language that is more valuable for simulations. Understanding machine learning concepts and combining them with finite element analysis will open exciting opportunities in modern engineering research and industries. So, these are some of the closing remarks before I conclude the today's session. So engineering mechanics remain the basic foundation of all structural and mechanical design. Statics and dynamics help engineers to accurately analyze the forces and motion. Artificial intelligence is enhancing simulation optimization and prediction capabilities across industries. However, strong foundations are still essential because AI supports engineering thinking rather than replacing it. So with this, I thank all the members for attending the today's online session. We will meet in the next upcoming lecture series. Thank you all.